All right, students, so now we're here with circles and a coordinate plane. So we've talked about circles a ton. Finish up circles. We're going to spend a couple days talking about what happens when a circle is in a coordinate plane. All right, so let's just start here. Here's a good old circle in a coordinate plane. And we're going to draw a radius to any of the 8 points. So we could do it here, 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 so on and so forth. It doesn't matter. Let's just do that one. Why not? Okay. This is the radius of the circle. That's what R means, all right? Now we're going to find the length of the radius. Hint, we're going to use the distance formula. Or let's simplify it a little bit, and let's just use Pythagorean theorem shortcut. All right, make it good old right triangle. Call this side A, it's 3. This side B, it's 2. And R is the hypotenuse. So instead of saying C squared, we're going to say R squared equals A squared plus B squared. So R squared is going to equal 3 squared plus 2 squared. R squared is going to equal 9 plus 4, also known as 13. So R equals the square root of 13. Remember, R squared equals 13. So R equals the square root of 13, which is about 3.6. All right, so that's just kind of phase one of talking about circles in a coordinate plane, is how do we compute the radius of a circle. All right, so we got a good old number, radical 13, which is very close to 3.6. All right, so now we're going to draw, now we're here, and given this graph, we're going to draw a radius to the point xy shown on the graph. So this is just some random point xy on the graph. Oops. We're going to call that R. All right, if R represents the length of the radius, write an expression of R squared. Hint, think of Pythagorean theorem. So we already did this kind of just above, but we made a right triangle. All right, this distance is X, this distance is Y. And let me rewrite R. Oops. Oopsies. And we'll call that R, the radius. All right, so instead of saying R squared equals A squared plus B squared, we're going to say R squared equals X squared plus Y squared. All right, so above, this was going to a specific point. Specifically, we found the radius when we were going to 3, 2. Now we just found the radius when we went to a random point, x, y. And then for fun, like super duper fun, I can take the square root of both sides. So R specifically equals the square root of x squared plus y squared. Okay, cool. All right, and this is slowly foreshadowing to something super duper cool. All right. So given the graph on the right, we're going to label the coordinates of the center and plot the point on the circumference. All right. So this is the center. I'm going to write it over here. The center of the circle is 1, 3. Some random point on the circle is 2, 5. All right. Now we're going to draw a radius, and we're going to find the length of this radius. All right. Boop. There's the radius. Again, we could be using the distance formula every single time for this, but ain't nobody got time for that. So we're just going to use Pythagorean theorem shortcut. So R squared. I'm going to say X squared plus Y squared. Again, Pythagorean theorem shortcut. This is just the circle versions rather than say A, B, and C. We're saying R, X, and Y. So we're specifically going to have R squared. And then remember, I could even write R equals the square root of X squared plus Y squared. It's the same thing, just presented differently. And then I could even say, well, X was 1, Y was 3. Excuse me, 2. Because I'm using these numbers right here. And then computing that, I'm going to get R equals the square root of 1 plus 4, which is the square root of 5, which is approximately, square root of 5 is approximately 2.2. All right, that's it for this page. Stay tuned for the next page.